Hello students, welcome to Aditya Academy. I am Dr. Ragini Arora and today we are going to start exercise 8.3 from NCERT. I hope you must have watched previous 3 videos of this chapter and the basic concepts are clear to you. Now in this video we are going to start about the trigonometric identities. Now the first question is, express the trigonometric ratios sin A, secant A and tan A in terms of cot A. Now, before starting this question, let me tell you the basic 3 identities that we can use as the standard results. As we use theorems in case of geometry, we have 3 basic identities which are sine square theta plus cos square theta is equal to 1. Second one is 1 plus tan square theta is equal to secant square theta. Third one is 1 plus cot square theta is equal to cosec square theta. So these are the 3 basic identities that we can use as standard results to solve further questions. Right? Now in first question we are supposed to express trigonometric ratios of sin A, secant A and tan A in terms of cot A. Right? So now we have to start with cot and express these 3 ratios in terms of cot only. So I'm starting with this relationship. Right? This is cosec square A is equal to 1 plus cot square A. So how we can write cosec A? Cosec A is square root of 1 plus cot square A. Now first we had to find sine A. So what is sine A? Sine is the reciprocal of cosec. 1 upon cosec A. So we can write sine A as reciprocal of this. That means 1 upon under root of 1 plus cot square A. Right? So this we have got. This is the first result. Second is we have to express secant A in terms of cot A. So now I am taking this relationship, this one. Secant square A can be written as 1 plus tan square A. Now here I can change tan square A in terms of cot square A. We know that cot is the reciprocal of tan and tan is the reciprocal of cot. So we have, this is 1 upon cot square A. So we can write secant square A is equal to cot square A plus 1 upon cot square A. So finally we can take the value of secant A as square root of this whole term, cot square A plus 1 upon cot square A, which ultimately can be written as under root of 1 plus cot square A, and we can take out the square root of cot square A, which is cot A. So secant A can be written as this in terms of cot A. This is the second result we have got. Third one itself is tan A. Tan A is nothing but the reciprocal of 1 upon reciprocal of cot A. So tan A is 1 upon cot A. This is the third relationship that we were supposed to write. So next we have write all the other trigonometric ratios of angle A in terms of secant A. So here we have to write all the 6 trigonometric ratios, 5 trigonometric ratios, because one is given as secant A itself. Right? So secant A is the basic. Secant A is the first trigonometric ratio. Then we have cos of A, which is 1 upon secant A. This is the second basic result. Right? Next we can start with the identity like 1 plus tan square A is equal to secant square A. So we can write tan square A is secant square A minus 1. So what we can write as tan A? Tan A is square root of secant square A minus 1. This becomes the third relationship or third trigonometric identity that we have got. Now what is rest? We have cos and tan and secant A. So next what we can do is we can start with like 1 plus cot square A is equal to cosec square A. So what we can do here is cosec square A is equal to 1 plus cot square A, right? And how can we remove this cot square A? This is 1 plus 1 upon tan square A. So we have cosec square A as 1 plus tan square A upon tan square A. And what we can do here, 1 plus tan square A is secant square A. Right? From the identity, 1 plus tan square A is secant square A. Now denominator is tan square A. And tan square A from here can be written as secant square A minus 1. Right? This is cosec square A. Now for cosec A, we can take the square root. This is secant square A upon secant square A minus 1. Denominator cannot be solved, but in the numerator we can take out this secant A outside the root. This is secant square A minus 1. Right? So this is our fourth trigonometric ratio. Now sin A is simply the reciprocal of cosec A. So we can write this as secant square A minus 1 under the root upon secant A. This is our fifth ratio. And the last one is cot of A. Cot of A is the reciprocal of tangent of A. Right? So tangent of A is square root of sec square A minus 1. So we can write this as under root of 1 upon secant square A minus 1. So this is our sixth trigonometric ratio. Right? Now the next question is, we have to choose the correct option for the given expressions. This is very basic question. It is 9 secant square A minus 9 tan square A. First of all, we take out 9 common. So we have secant square A minus tan square A. And from the identity, 1 plus tan square A is equal to secant square A. We can write this as 1 is equal to secant square A minus tan square A. Right? So we can replace secant square A minus tan square A by 1. So this becomes 9 multiplied by 1 is equal to 9. So this option B is the right answer. Answer is option B, that is 9. Right? Next we have to simplify this expression and check what is the correct answer. So we have 1 plus tan theta plus secant theta. In this we have 1 plus cot theta minus cosec theta. Now we simplify this expression. What we can do is 1 plus, this is tan theta can be written as sin theta upon cos theta. And this itself is 1 upon cos theta. Then we have cot theta can be written as cos theta upon sin theta. And this itself is, cosec is the reciprocal of sin. This is 1 upon sin theta. Now what we can do here is, we can simplify by taking. Now what we can do here is, cos theta becomes the LCM. So we have cos theta in the numerator, cos theta by cos theta 1 multiplied by sin theta, and here we have 1. Right? So now if we take here sin theta as the LCM, sin theta gets multiplied by 1, so it is sin theta. Next we have 1 multiplied by cos theta is cos theta, minus 1 multiplied by 1 is this. So now what we can do, see in the numerator we have cos theta plus sin theta plus cos theta. If we treat this as our A, this is A plus 1 can be taken as B. So this expression in the numerator in the first bracket is A plus B. In the second bracket it becomes A minus B. So what we can do here is, this is cos theta plus sin theta. Instead of multiplying every term by every term and opening it, you can do it smartly. This is a square. The sign of both the terms here and the second fraction is same. So I'm taking this as a square, and we have different signs for 1. So we can treat 1 as b. It is a plus b, a minus b. So a square minus b square. And in the denominator we have cos theta into sin theta. Right? So what we can do here is open this by using identity a square plus b square plus 2ab plus 2ab, 2 sin theta cos theta, minus 1. In denominator we have cos theta sin theta, what is equal to sine in all the steps. So next what we can do is, here cos square theta plus sin square theta is 1. 1 plus 2 sin theta cos theta minus 1 upon cos theta sin theta. Right? So now this 1 and 1 get reduced. We have 2 sin theta cos theta divided by sin theta cos theta. So now we can reduce this and get value 2. So here we have 2 as the option C. Right? So answer becomes option C, that is 2. I hope this is clear. Next is, we have in bracket secant A plus tangent A multiplied by 1 minus sine A. So now we have to simplify this expression to choose one of these options. So what we can do is, secant A can be written as 1 upon cos A. Tan A can be written as sine A upon cos A. Right? And in this bracket, this is 1 minus sine A. So now we have, taking cos A as the denominator, we can write this numerator as 1 plus sine A. Right? And in bracket we have 1 minus sine. Now if you check for the numerator, we have 2 brackets in the numerator, which is 1 plus sine A and 1 minus sine A, which gives us a plus b, a minus b. So we can write this as a square minus b square. 1 square is 1 minus sine square a upon cos a. And what happens? This is the identity. You can write the basic identity is sine square theta plus cos square theta is equal to 1. So by the value of 1 minus sine square theta, you can replace cos square theta. 1 minus sine square theta is cos square theta. This is cos square a upon cos a. So now I can reduce this and we get value cos a. Now check for the right option. This is secant a, sine a, cosecant a and cos a. So answer is option D, which is cos a. Right? So next is the fourth part. This is 1 plus tan square a upon 1 plus cot square a. So you have to simplify this. Right? This is the last question for this video. Next, for the fourth question, they are all identities. We will be dealing with the next video. Now 1 plus tan square a upon 1 plus cot square a. Now if you remember those identities, I am writing it once again. 1 plus tan square a directly gives us the value of secant square a. And 1 plus cot square a gives us the value of cosec square a. So we can simply put these values. This is equal to secant square a. And this is cosec square a. Right? Now, we don't have either of these things, so we have to simplify it further. Secant square a can be written as 1 upon cos square a, and this can be written as 1 upon sine square a. Both are fractions in a bigger fraction, so we can write it like 1 upon cos square a, and this can be flipped, sine square a over 1. So finally we have sine square a upon cos square a, which is tan square a. You can see that this is the last option, D. So answer becomes option D, that is tan square a. Right? So now we have solved first three questions of this exercise 8.3. I hope these are very basic questions and you're comfortable with this. Next, we have question 4, in which we have different parts of all the identities we have to prove. That we will do in the next video. I hope this is clear to you and like watching this video. Please like, subscribe and share it with your friends. Thank you.